Section 2.6, absolute value inequality. It's going to start with one vocabulary term, and that would be absolute value inequality. The definition is going to be very mind-blowing to you. It's an inequality that contains an absolute value expression. There's nothing really more we can say about that. We kind of use the term in its own definition, but it should make sense. An inequality that contains an absolute value expression. So number one, solve and graph. The absolute value of x is greater than 2. What this question is really asking is, what number or numbers, and really it's not number or numbers, it's what numbers, because we're talking inequality. What numbers are more than 2 units away from 0? That's really what this inequality is asking, or what it's stating, is what numbers are more than 2 units away from 0. So if we look at a number line, we got 1, 2, 3, 4, 5. We'll put 0 here, 1, 2, -1, -2. If we wanted to put 3 and -3, we could certainly do that. So what numbers are more than 2 units away from 0? Well, that's everything outside of the 2's, okay, to the left. So our answer here for number 1 would be, well, we could say that x is greater than 2. Any number bigger than 2 is more than 2 units away from 0. And then anything to the left of -2 would also be farther than 2 away from 0. Okay, so this would be our answer right here. X is greater than 2, or x is less than -2. Okay, so that's a very basic example. Let's try another one here. The absolute value of a is less than or equal to 4. So if we look at a big number line, I'm going to try to get all of them on here. So 4, 3, 2, 1, 0, 1, 2, 3, 4, and we'll put 1 there. So we'll put another one there. So -5, -3, -1, 0, 1, 2, 3, 4, 5. So we're looking for, this is -4 and -2. We're looking for, what numbers, in this question, what numbers are 4 or less away from 0? Well, 0 would be less than 4. 1 would be less than 4. 2 would be less than 4. 3 would be less than 4. 4 is exactly 4 units away, and that one counts this time because we have the or equal to part. But we can't use 5 because 5 is more than 4 away from 0. And we couldn't go anything farther to the right of 4. If we go to the left side of 0, -1 is only 1 unit away, that counts. -2 would count, -3 would count, -4 would count, -5 would not, because now we're getting bigger than 4 units away. So our answer, or the solutions, are all the numbers in between the 4's, including the 4's. Okay, so +4 and -4. Okay, so our answer here, we could have x is less than or equal to 4, and then we could also have x is greater than or equal to -4. And since we're shading in between these two numbers, we can make this an and inequality. And another way to write an and inequality, we'd have the small number followed by less than or equal to our variable, and it wouldn't be x this time, my mistake there. It would be a less than or equal to +4. The small number less than or equal to the variable, less than or equal to the big number. Okay, so this would be our answer for number 2. Let's take a look at number 3. Z is greater than or equal to 7. So we're thinking about what numbers are more than 7 units away from 0. I'm not going to put all the numbers on the number line here. We're going to have -7, we're going to have +7. Hopefully what you're noticing is that we're using the positive and the negative number on the outside in our number line. So this question is asking what numbers are more than 7 units away from 0. Well, 0 is obviously here in the middle. So if we start at 7, could we include 7? The answer here is yes, because we have the or equal to part. Okay, so we want numbers that are more than 7 units away. That is out to the right, because 8 would be more than 7 units away. 100 would be more than 7 units away. Okay, so anything 7 and to the right counts as a solution. If we look at -7, -7 would count because it's exactly 7 units away, and because we have that or equal to part again. And anything farther away from 0 has to be out to the left. Okay, so like -8 or -10 or -50. Okay, all of those numbers would be more than 7 units away. So we can think about this. What would be our inequality that would match this graph? Well, we would have z is less than or equal to -7, or z is greater than or equal to +7. Okay, so those are three basic absolute value inequalities. Hopefully these are kind of making sense. We're going to have time in class to answer questions, obviously, but we're not done with the video. We're going to do lots more of examples and continue to work with this. Okay, so the basic idea with solving absolute value inequalities. The first inequality, it's going to be normal. You just drop the brackets and then you solve it like normal. For the second inequality, because remember, just like equations, we have a second inequality. We need to what I call flip the sign, and I'll show you what that means in just a second. Okay, so number one, solving graph. So the first inequality, we just drop the signs, normal. So we make it x plus 7 is greater than or equal to 2, and we'll solve from there. So all we got to do is subtract 7 from both sides, and we got x is greater than or equal to -5. So there's our first part of the solution. The second part, so flip the sign, So for this part, we keep the same on the left, so we just drop the brackets, x plus 7. And when I say flip the sign, I mean flip the inequality sign. So instead of greater than or equal to, it's now less than or equal to. And instead of positive 2, it's now going to be -2. We flip the inequality sign, we flip the sign on the number on the right. And then we go from there. Still a one-step equation. So we've got x is less than or equal to, this time it's going to be -9. Okay, so if we wanted to graph, the smaller number goes on the left. In this case it's -9. -5 is the bigger one. We're going to have closed circles at both. Okay, so closed at both. If we look at 5, it says x is greater than or equal to -5, so that would be out to the right. And it says x is less than or equal to -9, so less than is to the left. So this one would be an OR inequality because our arrows are pointing opposite directions. There is no common number that would satisfy both inequalities. Okay, so the actual solution would be this, and then the graph is accompanying. Okay, let's try another one. Number 2, the absolute value of x minus 3 is less than 3. So the first inequality, just drop the brackets. X minus 3 is less than 3. Second inequality, drop the brackets, x minus 3, flip the sign. Okay, so flip the sign from this time less than to greater than, flip it from +3 to -3, and then we'll solve both. So again, we got one-step inequalities here. So plus 3, x is less than 6, and then plus 3, x is greater than 0, and then let's go ahead and sketch a graph. So I'm going to have my two numbers. 0 is obviously the smaller of the two, so 0 goes to the left. I'm going to have open circles at both. Okay, so this says x is greater than 0. Greater than is to the right, this way. And x less than 6 means we're going to the left from 6. So our inequality, or our solutions, are in between 0 and 6. This would be an AND inequality. If you want to rewrite it, so you have just the one condensed inequality. We start with our small number, our variables in the middle, our big number, and we've got less thans in between both of them. Let's try something a little more difficult. 4 times the absolute value of 2x minus 5 plus 1. Before we can do any flipping the signs or dropping brackets or anything like that, we have got to get the absolute value bracket by itself. So I'm going to write this up here. Get the bracket alone first. Okay, we've got to get the bracket alone first. The way we're going to do that is by using our algebra skills. We're going to get rid of the 1, so minus 1, so we'll have 4 times the absolute value of 2x minus 5 is greater than, let's see, 21 minus 1 is 20. Then we got to get rid of the 4 out front. I'm going to do that by dividing. Okay, so the 4's will cancel. I'm left with absolute value of 2x minus 5 is greater than 5. Now we're at a place where we can actually drop some brackets and start solving some inequalities. Okay, so once the bracket is by itself, now we can go ahead and do this. We can have 2x minus 5 is greater than 5, so our first inequality. Second inequality, drop the bracket, 2x minus 5, flip the sign, okay? And then we'll go from there. So we'll add 5 to both sides, plus 5. 2x is greater than 10, which means x is greater than 5. And then for this one, 2x plus 5, we're going to add 5 again. So 2x is less than 0. Okay, divide by 2. 0 divided by 2 is still 0. So I've got x is greater than 5 and x is less than 0. So if I want to go ahead and sketch my graph, I'm running out of room here. 0's on the left, 5's on the right. We've got open circles at both. It says x is less than 0. I'm looking right here. x is less than 0, so at 0 I need to go less than. Less than is always out to the left, so that is this way. And we'll need a bold arrow. And it says x is greater than 5, so from 5 we need to go out to the right. Bigger numbers are always out to the right. Okay, so there's your graph. It's a small one, but it is correct. All right, number 4. I made a mistake when I typed this. That should be greater than or equal to. Greater than or equal to. Okay, so 3 times the absolute value of d plus 1 minus 7 is greater than or equal to negative 1. Again, we've got the bracket where we've got to get the bracket by itself before we can do anything else. Okay, so I'm going to add 7 to both sides. So 3 times the absolute value of d plus 1 is greater than or equal to, let's see, negative 1 plus 7 is 6. We'll divide both sides by 3. So the 3's will cancel. The absolute value of d plus 1 is greater than or equal to 6 divided by 3 is 2. Now that we've got the bracket by itself, now we can go ahead and split this up. So we lose the brackets for the first one, d plus 1 greater than or equal to 2. Just drop the brackets and you've got one. For the second inequality, drop the brackets, d plus 1, flip the sign, flip the sign. Okay, so d plus 1 is less than or equal to negative 2. All right, so let's go ahead and solve. These are one-step inequalities. These shouldn't be too bad. We're going to subtract 1, so d is greater than or equal to 1. Subtract 1 again, we'll have d is less than or equal to negative 3. Okay, so let's go ahead and graph. We got a little more room down here at the bottom. So negative 3 is smaller, 1 is bigger. We're going to have closed circles at both this time. And let's see, from negative 3, it says d is less than or equal to negative 3. So that means we need to go to the right. And again, a bold arrow. And from 1, it says d is greater than or equal to 1. Greater than is always out to the right. So again, our arrows are going to be pointing in opposite directions. I hope you're finding these aren't too difficult. The biggest key, especially when you get more complicated inequalities like this one, like these two, number 3 and number 4 here, the biggest thing is we have to get the bracket by itself before we do any splitting. Okay, we're only getting the bracket by itself in this step in orange. Once we get the bracket by itself, then we can split it into two separate inequalities. Okay, we cannot switch these signs until we've got the bracket by itself. So don't even think about doing that until you get to this point where the bracket is by itself. Then you can drop the brackets and then do some flipping of signs. All right, got a couple more here for you. Number 5, absolute value of 8x minus 11 is less than 0. So let's think about this question. This says that whatever number we come up with, so we come up with an x, we plug it in, and we get a number in the end. It says the absolute value, or the distance from 0, is less than 0. Is it possible, so this says the absolute value of our number, whatever it might be, is less than 0. What that means is that the distance from 0 is less than 0. Is that possible? The answer there is no. It's not possible to have a distance smaller than 0. Okay? The smallest distance you can have is 0. The only answer for this is no solution. It's not possible. Whoops, let me spell possible correct. Not possible to have a distance less than 0. Okay, and that's really what the question is asking, is what numbers have a distance that's less than 0? It's not possible. There are none. So your answer for number 5 would be no solution. Now number 6 says 10 minus m, the absolute value of 10 minus m is greater than or equal to negative 2. So this says the distance here, what this is saying, the distance of whatever 10 minus m might be is bigger than negative 2. The smallest distance we can have with this one, with any of these absolute value inequalities, is 0. So what numbers have a distance that's bigger than negative 2? Well, that would be all of them. There's no number on a number line that's smaller than 0, and it's asking for all numbers that are bigger than negative 2, which is all of them. So your answer here is all real numbers, or infinitely many solutions. I don't know that I would actually put infinitely many solutions. All real numbers makes more sense for number 6. Okay, all real numbers. You can pick any number you want, put it in there for m, take the absolute value of 10 minus m, you are going to get something that's bigger than -2. The smallest distance you could ever come up with for an m would be, or for the absolute value of 10 minus m would be 0. And 0 is always going to be greater than -2. So any number you pick for m is going to give you a solution. Just like with this one, if you pick any x, plug it in, you're never going to have a distance that is less than 0. The smallest distance you can ever have is 0 itself. Okay, so there are a couple of strange absolute value scenarios. Make sure you do keep a lookout for them. They won't happen a whole lot, but they do happen occasionally. Just wanted to show you these so that you are aware. Hopefully you don't get caught off guard, or you come up with an actual solution when it's not possible to have a single inequality be a solution, especially for one like number 5 or number 6.